Well, for us, it's a highlight, not for 3i Atlas. It avoided the Earth, actually, when it came closest to the sun. It was on the other side of the sun. We couldn't observe it from Earth. However, today, it's closest to Earth, and that's a great opportunity for us to observe it because it's also a new moon. So there isn't much moonlight in the night sky. What is unusual, and we realized it only recently, is that there is an antitail, a jet pointed at the sun, still in existence, even though now it's in the opposite direction to the motion of the object. What we saw before, when the object was approaching the sun, we saw a jet pointed at the sun in the direction of motion. And in addition, we learned this week that the rotation axis of this object is also directed at the sun because the jet was wobbling around it. And that means that the object had a permanent day side from the sun-facing side and a permanent night side on the other side. You know, that is different from the Earth, where the rotation axis is nearly perpendicular to the direction to the sun. So a day changes into night for us on almost every point except for the poles. And so that is unusual because it means also that the jet came, the base of the jet is close to the pole of this object. And now, after it passed closest to the sun, there is a different jet coming from the other pole. And the question is, how do we get these tightly collimated jets? They seem to be at least 10 times longer than they are wide. And if you just have a pocket of ice on the surface of a rock, you would expect when the sun illuminates it for it to evaporate in all directions. So you won't get a collimated jet out of that unless there is a hole in the ground. But in that case, it will be warmed up only when the sun is overhead and just for a short time. So it's not at all clear how a natural pocket of ice will end up producing a collimated jet. And that raises the possibility that maybe it's something else. You know, obviously, if there is a technological thruster, you would get a collimated jet. And perhaps there is this antitail, a jet pointed at the sun, to protect the object from the solar wind. That could be a technological reason for it. However, I should say that based on my assessment, it's most likely a natural object, but extremely unusual, very rare, and we need to figure it out. And for that, the coming days and weeks will offer us a wealth of information, because right now there are hundreds of observatories around the Earth that will observe it, as well as the Webb telescope. The Hubble telescope gave us an image just a few weeks ago. So we will know much more in the coming weeks. And, you know, that's the fun of doing science, because we can stay curious and just figure things out, like the work of a detective. Well, there was no smoking gun, a conclusive piece of evidence that would indicate that there are objects that were manufactured by non-human intelligence near Earth. But there are lots of reports that are intriguing. And my approach to that is, of course, if the government were to come forward and release the data, it would be fantastic, because then we can look at it and ask, does it really suggest that? But they haven't done so. And if they do have information, materials, data, if it's from 50 years ago, it makes no sense to keep it classified, because any technology used by adversarial nations would have been completely irrelevant nowadays from 50 years ago. So if there is something that is old, it should be released to the public, and scientists like myself would love to look into it. The other thing we can do is obviously observe the sky and look for any outliers, unusual objects that operate in ways that go beyond the performance envelope of familiar technologies. And that's what I'm doing by leading the Galileo project. We have 3 observatories, and we will be monitoring millions of objects in the sky in the coming year. And if we see anything unusual, we'll let everyone know, because we are not particularly interested in human-made objects. It was discovered on July 1st. Not a great timing as far as I'm concerned, because my wife wanted us to go for a vacation in Cancun. And As I arrived, I immediately realized this object is unusual because it's very bright, and if the brightness of the object was a result of a solid body reflecting sunlight, it should have been of order the length of Manhattan Island, the same size as the asteroid that killed the dinosaurs 66 million years ago. That's a very rare object that, in fact, there is not enough material in interstellar space to deliver such an object to our backyard once per decade. And that it triggered my interest, and I wrote a scientific paper while my wife enjoyed the vacation. But that was just the first clue. And then I realized, in fact, the object is traveling in the plane of the planets around the sun to within 5 degrees. And the chance of that happening at random is 1 in 500. So why do we have this alignment, which, by the way, is a great fortune because we can observe the object for a very long time. We've already observed it for almost 5 to 6 months, and we will continue to observe it for a few more months. And that would not have been the case if it were to come at a large angle relative to where all our space assets are. You know, the observatories that we have, either on Earth or in space, are all located in that plane. And so that was surprising, and I thought, well, maybe it was sent in that plane. I mean, there is no reason for such an alignment, given that it's only the third object, and the chance is 1 in 500. And actually, the plane of the Milky Way disk is misaligned by 60 degrees. So you can't explain this by saying, oh, the object came from the Milky Way galaxy. Of course, I mean, this is just one object that we recently identified in our backyard. And, you know, if it's a comet, a natural object, there were billions of similar objects that visited us before. So this is a relatively large object. There are many more smaller objects that we can't see because they don't reflect enough sunlight. We can only see them if they happen to collide with Earth and appear as a meteor. And there was one from 2014, half a meter in size, that collided with Earth and was moving roughly at the same speed as 3I Atlas. And I discovered it with my undergraduate student, Amir Siraj, back then, and about 5 years ago. And I led an expedition to the Pacific Ocean to look for the materials from that object because it was the first recognized interstellar meteor. So there are plenty of those objects if they are natural rocks, or however, there might be a disproportionate fraction of those that have a technological objective, that come to visit the inner solar system for a reason. And that, of course, is the most interesting finding that we can have, because, you know, if we find a rock, the best we can hope for is maybe taking a small sample of it and checking whether the material has the building blocks of life, because this rock came from another star, and traveling to that star will take us millions to billions of years. That's the best you can hope to do with a rock that arrives to our backyard from another star. But if it happens to be a technological object, of course, we would like to get a close picture of it. And if we find that there are buttons on it, we might use the robotic arm of a lander to press a button and see what happens. Yeah, that is difficult because you should think of people in a way that it resembles AI systems. And as we know, the large language models are as good as the training data set that they have. So if you take people and train them on icebergs or icy rocks in space, and you say, these are the objects that we found in space in the past, they would always identify any object in the sky as a space rock, as a natural object, because that's what they're trained on. And that's the way you should think of, comet experts. That's what they worked on for decades. And all I'm asking them is to expand their training data set, because we know that we launched equipment to space and that there are not only rocks there. And assuming that we are the most accomplished technological civilization is really arrogant, because, the sun arrived to the scene only in the last 1/3 of cosmic history. Most stars formed billions of years before the sun. And there could have been many space entrepreneurs out there that are far more accomplished than Elon Musk. And we should approach this with a sense of modesty and just keep our eyes up and see if there is anything coming our way. And just on January 2nd this year, there was an object near Earth that was classified by the Minor Planet Center, the official organization, as a near-Earth asteroid. And then within a day, they realized that it moves along the path of the Tesla Roadster car that was launched by SpaceX. So then they removed it from their catalog and said, sorry, it's not a rock, it's a car. And the only reason they could do that is because they knew about the object that was launched by humans. But if there was another company near another star that would launch a car, an interstellar car, that would have been classified as a rock of a type that we've never seen before. The antitail, the jet that we see, which is 10 times longer than it is wide, stretching out to about 1 million kilometers. We've never seen anything like it before. I mean, when people look superficially at the images of 3I Atlas, they say, oh, look, there is a tail. But you have to realize where the sun is located relative to 3I Atlas. And it's not a tail, it's an antitail, meaning that it's not being stretched away from the sun by radiation pressure or the solar wind. Instead, it's actually pointing towards the sun, and it goes out to 1 million kilometers away from the object. So that's bigger, that's a few times bigger than the distance to the moon from the Earth. Just imagine a jet coming from the Earth and going a distance that is bigger than the distance to the moon. That's the jet we are witnessing. And it's not the standard cometary tail, it's an antitail. And not many astronomers are actually trying to explain it. They say it's a comet, but then how do you explain the antitail? We have to come up with a reason for it, and we have to explain why it's so tightly collimated, 10 times longer than it is wide. And why is it also persistent? Because previously the object was facing the sun from one pole of its rotation axis, call it the North Pole. And now, as the object is receding from the sun, there is an antitail coming from the South Pole, the other side of the object. And why would there be a pocket of ice symmetrically, exactly at the poles? And why would you get it to produce a collimated jet like that, like a beam of particles coming out of it? These are questions that were not addressed by any of the comet experts. And if you look at the press conference of NASA, for example, they haven't discussed anomalies like that, or the alignment of the trajectory of 3I Atlas with the plane of the planets around the sun. My hope is it will not deliver any unwanted gifts to Earth. I don't think there is anything special about its distance from Earth right now, but it would be interesting to watch out what happens on March 16th when it gets closest to Jupiter, because it arrives just at the right distance from Jupiter for Jupiter's gravity to dominate over the sun's gravity. And maybe there is a reason for that. Maybe it will deploy some objects there. Already, near Mars, there was something really strange. Several NASA spacecraft were looking at it, like the Mars Reconnaissance Orbiter and MAVEN. And then a couple of months later, MAVEN disappeared. I mean, we lost contact with it. NASA cannot establish any signal from MAVEN. And it arrived at Mars 11 years ago. So this spacecraft was operating very well for a very long time. And suddenly, we can't contact it anymore. So one thing to remember is that we arrived late to the party, the cosmic party. First of all, the sun formed in the last 1/3 of cosmic history, but more importantly, humans arrived at Earth, on Earth, just over the past few million years, which is 1 part in 1,000 of the history of Earth. So if you just imagine an object like 3I Atlas, it was probably sent to the journey billions of years ago. That's the amount of time it takes at its speed to cross the Milky Way galaxy disk. So that means that at that time, the Earth was not particularly interesting. It was a tiny planet, and life was very primitive, and there might have been a completely different reason to send a technological object to the solar system. And Jupiter was back then and is still now the most massive planet in the solar system. I mean, it's much more massive than the Earth, much more easy to detect from a large distance. And so, we tend to think that even though we arrived late to the party, someone would like to dance with us. And if they come to visit the solar system, they would definitely be interested in us. Well, that's very self-centered. And, we also ask, where is everybody? Of course, the answer may be that they don't care much about us. And we have to seek them, to look for them. We need to be proactive. We need to check if objects arriving into the solar system are only rocks, or maybe among them there are some tennis balls thrown by neighbors or some technological objects. That's our responsibility of staying curious and finding out our neighbors. I mean, that's what you learn when you go dating. I mean, not everyone is as good looking as our most celebrated actors in Hollywood, and so very often you find people who are not interested in you. And, we should accept that, because we already know that we are not at the center of the universe. And so why should we be at the center of attention in our local neighborhood? I think about science as science of the people, that anyone who is curious should view science as really a commonsensical thing to do. Like collecting as much data and evidence and clues. That's what a detective does when trying to crack the mystery of a crime. And the same happens in the context of science. We are just building instruments to help us figure out things. And everyone can be part of that. It's not the work of the elite. It's any person is encouraged to try and participate in that endeavor. And I got a lot of emails from parents who tell me that their kids now want to become scientists. And I love that. This is the biggest reward, I think, from the passage of 3I Atlas, if it happens to be a rock. So, in fact, we have the Rubin Observatory in Chile that was funded by the National Science Foundation and the Department of Energy. And it just started its work, and it has a 3.2 gigapixel camera that is 1,000 times higher resolution than your cell phone camera. So it should survey the southern sky every 4 days and potentially discover an interstellar object every few months. So that means 100 times more objects per year will be discovered than before the Rubin Observatory came to exist. And we should start in 2026, and it will continue for the next decade. Now, the only thing is we have it only in the southern sky. It would have been nice if we had a similar survey telescope, a twin telescope that covers the northern sky. But at any event, there will be more to come, and you should always believe that the best is yet to come. At least that is my approach. For example, just to give an example, I used to have a lot of file cabinets in my office at Harvard because I was chair of the astronomy department for 9 years, with a lot of material about people, about correspondences, and so forth. And one day I received a note that an artist named Greg Wyatt would like to donate 2 bronze sculptures of Galileo Galilei to my office, plus 51 watercolors that he created. And I fell in love with his generosity. And basically, I got rid of the file cabinets. I told my administrator, they represent the past. I don't care about the past. I only care about the future. And it's really because I believe that the best is yet to come. Because if we do discover a technological artifact that originated from another civilization, then everything will change. Then $1 billion will sound really like a small sum of money, because we would realize that, if one of these objects is interested in Earth, it could be a potential threat. So we need a planetary defense warning system, a system of interceptors that will come close to every unusual object that comes to our backyard and take a close-up photograph and inform us whether it's a rock or something else. And that could cost much more than $1 billion. But I do see it as the future if we really realize that we are not just receiving rocks from interstellar space. So I wrote a white paper to the United Nations urging them to consider the potential threat from an interstellar object seriously, just because, we are all in the same boat, all humans on Earth. And it could be a unifying theme, because if we realize there is such a threat, we would feel that all the conflicts that we engage in through the standard politics makes no sense. It's just like a group of kids that are playing and arguing with each other in a sandbox until they realize that someone is visiting them, and then they start to behave much better. I think if we realize that there is something, that we have a neighbor, then humanity might come together. That would be a unifying force. Now, the United Nations is the current organization that can deal with international affairs of this nature, and I suggested creating a committee or a sub-organization that would analyze the data we have on any interstellar object and decide how to respond to it policy-wise. But they are extremely slow in response. Instead, what happened a few weeks later is that the International Asteroid Warning Network decided to have a campaign, the one that you just mentioned, were starting on November 27th. For 2 months, they coordinate observations by hundreds of observatories on Earth, and in this way try to get as much data as possible about 3I Atlas. They claim that it's only a drill. They just want to test how well they can coordinate that. But I see it as a step in the right direction, that, the worst we can do is assume that we know the answer in advance, know that it's a comet, and therefore it's not of great interest, and then miss some of the data. So if this object now will behave in the coming weeks or months in an unusual way, we will immediately know about it because we are looking at it. I'm waiting for the data, and I would update it as soon as we have it. It may take a few weeks for the observers to release it, to make it public. As soon as I have access to the data that we will obtain around the time of closest approach to Earth, which is now, I will update my scale. Probably, my guess is in a month or so from now, because it takes time, and there are the holidays also that delay things. But if you ask me, what would be my wish? Let's say if I had the ability to do anything I want, I would love actually to board, to hitchhike 3I Atlas, to get to it and ride it towards the star, because it's moving much faster than any human-made spacecraft. For example, it had a rendezvous with 2 spacecraft. One is JUICE, on its way to Jupiter, and the second is the Europa Clipper, on its way to Jupiter. And these 2 human-made spacecraft will get to Jupiter in one of them in 2030 and the other one in 2031. And 3I Atlas will get to Jupiter in March 2026. Just think about it. They were close to each other, but 3I Atlas is moving so fast relative to them that it makes it in a much shorter time, and that's why I would love to ride it out of the solar system, because it would actually move faster than Voyager and New Horizons and Pioneer spacecraft that we launched, and this is the best opportunity to reach interstellar space at the shortest amount of time. I'm very much look forward to surprises. I would love to see something that I haven't expected. Just like this anti-tail, like the alignment of the plane of 3I Atlas with the orbital plane of the planets. For example, if 3I Atlas were to release objects near Jupiter, that would be amazing, because we can see them with, for example, the Juno spacecraft that is orbiting Jupiter. So I'm waiting for the unexpected. Because science, very often, if you look at the funding of science, projects are usually funded to study the known unknowns. In other words, things that we know about, but we don't fully understand them. So that's what science is doing, trying to study the known unknowns. However, the most exciting aspects of science is the unknown unknowns, meaning things that we don't even know that we don't know. I love that part of science where, you just bump on something that stumble on something that you haven't expected at all, and you didn't even know that you didn't know that.